Hello everyone and welcome to The Big Picture. So what we're talking about is how HTML and CSS and JavaScript and HTTP and APIs and all these things kind of plug together. So let's start with a diagram that you're going to be looking at for a long time, because this is just web apps in a nutshell. Your browser.
Hey Kyle, oh your camera's off. I don't know if you know.
What was it?
Oh, your camera's off.
My camera's off. My camera shouldn't be off. Oops. There we go. I'm back. So your browser is a magical tool that takes HTML and CSS and JavaScript and runs it. That is the purpose of a browser. And it's so good at it, it can take things like google.com and know how to translate that into a request for an IP address. So you type in google.com, your browser goes, hey, domain name service, can you tell me what the IP address is for this? And the domain name service goes, sure, here you go. And what's cool about DNS is that it's a whole chain. It's a phone book. That's all it is. Maps a domain name to an IP address. But you've got one in your computer. You've got one in your router. You've got one from your ISP. Your ISP has a whole network of them. So when you're trying to figure out what the IP address of something is, when your browser's trying to figure that out, it asks a whole bunch of those and eventually gets an IP address. Then you take that IP address, you request something from a file server. This is an easy thing to overcomplicate. Like it's literally just Google Drive. It's a folder that's got HTML files and JavaScript files and CSS files and image files and movie files. All it is a directory of files. You ask for one, and it sends you the contents of those files back. This is HTTP. So you make a GET request for index.html, and then your response is like the contents of that file. Now you also get some other like metadata about that, like what kind of language was processing this and what time it was fulfilled and whatever else. So this stuff comes in the body, and things like whether this was a successful request. So we get some of that from the status code and the status message. Other things we get from headers. So like that might be like content type. Telling the browser, by the way, the thing that I'm sending you right now is HTML. Just so you know. By the way, the thing I'm sending you right now is CSS. Just so you know. And that gives a hint to the browser about what it's supposed to do with the stuff in this body. Then it starts going through this HTML, and so that goes through here, and it turns it into the DOM. So all that HTML stuff head, body. The head maybe has scripts and links. Body's got paragraphs and anchors and whatever else. So it takes this HTML, turns it all into this stuff. When it comes across scripts and links and those kinds of things, it goes, oh, hey, wait, there's more files that I need. So it goes, gets those files. So the CSS stuff, those end up going into the DOM. All those CSS rules that you write end up getting applied to this stuff. The script stuff, though, when it comes across one of these, executes top to bottom. So when it gets this script back, first line of code, second line of code, third line of code, fourth line of code, starts at the top and starts going down to the bottom. Now, the thing that's pretty cool about JavaScript is that this DOM tree exists when we're doing this, which means that now we can program this stuff. So it starts out as just whatever we got back from the file server. Your browser starts chewing through it, builds out this tree. And then when it starts going through this script, we can add stuff to the tree. We can remove stuff to the tree. We can add events to the tree so that when this gets clicked on, or some event happens, we can have JavaScript that reacts to that. The other cool thing that we can do is if there's some data that we need that is not on the file server, it's not coded into these files or anything, we could have API data over here that might be backed up by a database. So API, you make an HTTP request, because that was part of this script over here. This might be like get Pokemon, get Star Wars movies. So then the data that you get back is JSON. As you're going through this script, it goes, by the way, whenever this data comes back, why don't you take this JSON, why don't you parse it into a JavaScript object, and hey, why don't we play with this tree a little bit? Why don't we take some of this data and turn it into a JavaScript object, and then we'll take that JavaScript object, we'll turn it into a DOM node, and then we'll throw it on this tree. And that is web app development. Everything from Facebook to like the Star Wars video library all basically works this way. Ask me some questions about it.
So once we do the actual fetch and then we parse out the response and make those into objects, all we're doing at that point is just playing with our tree and doing different things with that if we wanted a mental model for it.
Correct.
Cool.
Yeah, when you get something back from an API, you are turning it into DOM nodes. You're using that information to figure out which DOM nodes you should take out. You're using that to, I don't know, add event listeners to something. But the key thing is that JavaScript has the ability to change that tree after your browser builds it. And we can use data that we don't own, that came from somewhere else. Or even we do own it, it's just on a different computer somewhere. And we can use that to augment this DOM tree or replace it or do whatever we want. And at like an extreme level, like say you look at the LMS. So the Sika LMS, the HTML file for that, oops, it just tried to like actually open that. This is the HTML file for the Sika LMS that you guys use every day. That's it. Because it has this one div in the tree, JavaScript manages the entire tree, and it all just hangs off of that one thing. You could also have it so that it's mostly HTML. We just kind of have containers, and then we go fetch something from an API and then use that to put the data in. Both of those, totally normal things to do.
And at that point, you're just kind of divvying up what is the style of coding that I want to do.
Yeah. So this thing where like we don't really write any of the HTML out and we use JavaScript for all of it, that's called a single page application. So that's Angular, React, Vue, all that stuff is SPA stuff. It's called a single page application because there's one HTML file that the entire thing lives on, and JavaScript just manages what's showing up on the page itself without any other like files. Versus like what you guys have been doing with the Pokemon thing and the Star Wars thing, where we have like a shell that's sort of built out and we just like replace values. That's regular web app development. Hey, that's the name of this unit.
All right. Why does the API send back a JSON request as opposed to like what a file server does where it sends back actual HTML and body elements and stuff?
Sure. So that's a great question, and there's a couple reasons for it. One is that if this was sending back like the actual HTML that we wanted, there's a couple issues with that. One is that that's generally considered unsafe if you don't own it. Like if the Pokemon API was sending me back HTML and I'm just using something like .inner HTML to put that in there, you can also put scripts and like directly in HTML without being a separate JavaScript file, and that could be a malicious script. Pokemon API got hacked, and now they just have a whole bunch of scripts in there that pull files off your computer and send them via fetch over to bad guy's computer. So if you don't own the content, you generally don't want to parse HTML. I actually do the exact same thing with all your Markdown responses. So you write out some Markdown and you show that on the page. Markdown is just like a language that compiles to HTML. I don't run your Markdown as is because you can put just arbitrary like code inside of Markdown. Normally, you can write out HTML tags in the Markdown, works like normal. If you put script tags in there, you could run malicious scripts on my site that could really hurt stuff. And so I go through a whole bunch of other steps before that actually renders on the page. So it's kind of similar with this. That's reason number one. Reason number two is that this data might not be going to a web app. Here's what I mean. It might be going to a mobile app. That could also, like, that's not written in HTML and CSS and JavaScript. This might be written in Swift because it's an iOS app, or it might be written in Kotlin because it's an Android app. It still can make HTTP requests to this API and then get the data back and then do something with it. And if that's not enough, let's say it is just another HTML, CSS, or JavaScript app, somebody else's. Like the Pokemon API doesn't know what you want to do with that data. It doesn't know what format, how this should be displaying on your page. Because what you're doing for like the Pokemon app for Old Man Coberly's assignment might be totally different than what somebody else is doing with that data. So they just give you the raw data and then you figure out how you want to format, what you want to do with it, that kind of stuff. Bryce, does that answer the question?
Yeah, kind of. So just to clarify then, so the JSON being sent back is basically just, as opposed to HTML, it's just unformatted data being sent back that we can fetch and access. Okay.
Do whatever you want with.
Okay.
It's basically like you have this database where all that data is being held available in your browser. All these extra steps just give you access to that, and this person, and this person, and this person. And we can put security on this. Or like some of you noticed when you were working with the OMDB API, you had to use a key. That's what they use to throttle access, because like it's a free API. Like somebody could send 1 billion requests a day to that thing and just knock the server over because it can't handle them all. So it uses that key to check that you're only doing 1,000 requests a day. That sort of thing. So like you can kind of think of the API as like a gatekeeper for the data.
Thank you. That answers my question.
Excellent. More questions about how all these pieces fit together?
So seeing as it seems like you can pretty much create everything you could possibly want through JavaScript and whatnot, why is it that we bother with HTML at all?
Great question. So let me show you more of what the code for the LMS looks like, because it might look kind of familiar. So let's see. Good example would be inbox. So this is the code for inbox. Hey, wait a minute. That kind of looks a lot like HTML. A div with a class. It's called class name for some weird reason. At H1 is just sort of normal. Whoa, this looks like an HTML element that's not a normal HTML element. It is. Well, what is inbox coach? Hey, what do you know? It's a div. Another thing that kind of looks like an HTML element, but not one I've ever seen before. And then other stuff. What about that one? Hey, it's a div. Something that kind of looks like an HTML element. So even when we're doing all of this with JavaScript, it's still HTML.
So it's not so much that we're dismissing HTML, more so that it's being implemented through
Right.
Java.
And like this is a really key thing to understand. This is a thing that people usually don't get that confused about right now, but they get confused later on. Your browser understands exactly 3 things: HTML, CSS, and JavaScript. Those are the only ways to give instructions to the browser. Your browser doesn't understand React. Your browser doesn't understand TypeScript. Your browser doesn't understand any of this shit. If it shows up on the page, it needs to be like DOM nodes at a minimum. HTML tends to be a really good way to like write out this tree in a very human readable way. If something's getting styled, either we style these nodes directly. Oh, that's pretty awkward. CSS is a real good language for describing how this tree gets styled. And then working with the tree, JavaScript is the only language that does that. There have been attempts to have your browser do more languages that can manipulate that tree. There was one that Google made called Dart. It failed. Like everybody who's tried to do a different language in the browser has not taken. And it's because browsers aren't one thing. There's Google makes a browser, and Microsoft makes a browser, and Mozilla makes a browser. And so they do these things to published standards. But if Google goes, I wish the browser supported a different language, so we made Dart. Okay, well, if Microsoft and Mozilla and Apple don't agree with Google that Dart should be run in the browser, guess what? They don't add support for it, so it dies. So like this ends up being a remarkably stable thing. And there's one asterisk on this called Wasm that is a like successful attempt to run other languages in the browser. You will never come across this. This is more like, hey, what if the browser was also a games platform? Like Wasm will be awesome for that. But for making like apps that run in the browser, you're not going to do better in HTML and CSS and JavaScript. Because ultimately, the stuff that you see on the screen is this DOM tree. Your browser takes these trees and then makes it look like pictures on your screen. More questions about how all this works? Yep.
Yeah, just a quick side question. This isn't too important to the course, but a couple of weeks ago we were talking about web page gaming. Does that mean, so like some gaming companies were trying to get web apps, gaming into web apps, and does that mean the only 3 languages the browser would be able to still see through gaming would be HTML, CSS, and JavaScript?
That was the Wasm thing. So your browser reads in HTML and CSS, JavaScript, works with those directly. Now, your browser ultimately is just beeps and boops, all ones and zeros, right? So there's a couple levels in between JavaScript and ones and zeros. Wasm targets below JavaScript. It targets the same thing that JavaScript targets. And so it allows you to do things like run C++ in your browser. Games are a perfect use case for that. Web apps are not. Like, web apps are going to be made with HTML and CSS and JavaScript in perpetuity. But we could kind of supercharge the browser and do some other kinds of things that aren't web applications. Games is a good one. That's what Wasm is for.
Thank you.
I have a question.
Yeah.
So when it comes to like Steam,
Yeah.
which has game, like, you know, just a repository of games, right?
Yeah.
Like how can we as consumers play these games through the browser or through the app if technically like the only languages that the browser can understand is like, well, because it kind of seems to me like this is more like an alphabet of sorts, like HTML, CSS, and JS, and then like the languages we speak is just like a different language.
Sure.
You know, but going back to my original question, like Steam, like how does Steam work? Like,
Sure.
being able to play a game through the browser.
So with is Steam doing games through browsers now?
Or no?
That would be news to me. So
No.
let's take a look at Steam.
So.
That's not
So is it-
impossible, but
Is it like an app you download?
hang on. Let's take a look at Steam. That's a good example.
Because I'm pretty sure Steam is just the platform for you to be able to access the repository as it
Correct.
is of games.
Correct. So if I go over to Steam, all right, this looks like a web app if I ever seen one. So what's happening here is I went to steampowered.com. My browser looked up what the IP address for steampowered.com is, which is that right there. So if I put that in my browser, it should probably take me there too. Oh, it doesn't let me do that. Yeah, there's more and more places are shutting this down. It did make it to their server though. So that's the IP address for Steam. Then I requested nothing. There's no specific file that I requested. I didn't say like /index.html. So when you do that, the file server goes, all right, since you didn't request anything in particular, I'm assuming you mean index.html. And then it sends that back to me. So what that looks like is that. That was the HTML contents that the Steam file server sent back to me. So then my browser went through that. It turned all of this stuff into a tree. Built all that out. There was probably... So it went and also got this ICO file. That's the favicon. It went and got that from a static file server. All of these Akamai links here, these are all CSS. For every one of those, it went to some static file server and went and got this file, and then this file, and then this file. And so for each one of those, the CSS files, it just adds all those rules to the relevant DOM nodes. Hey, it comes across a script tag. So it stops, starts with this, then it does this one, then it does this one, then it does this one, then it does this one. All of these are Google Analytics. So that is keeping track of what I click on and then reporting that back to Valve and saying like, hey, somebody went to your site, they hung out on this page for 3 minutes. It was weird. They didn't really click on much of anything. They clicked on this button, they clicked on this button. All of those get sent back to Google, and then Google has a dashboard that Valve can look at that shows how most people tend to use their site. And this one here goes, all right, here's a JavaScript file. jQuery, good God, Valve. Come into the future with me. So it goes and downloads this jQuery JavaScript file. When it gets to that one, starts at the top, goes to the bottom. All jQuery does is adds a bunch of functions into your browser. And then there's another script here and another script there. So it's going through all of those. Some of these are adding event listeners. Some of these are adding elements. Some of these are making fetch requests. And so like, for example, if I look at this, let me refresh. That was HTML. There's some JSON. So like, there's a little bit of JSON. I'm guessing that they actually like built out all of this stuff on the HTML. If I go over here, one of these has to be making a bummer. So all of these like games and stuff are being kept in a database and being exposed as an API. And I know that because if you go to sites like Value My Steam Collection, there you go, Steam Calculator. So if I enter in my name, there we go. Yeah, it's got all of my stuff on here. I'm in good standing. So the reason it was able to do this is just somebody's app. This is like one of you guys. This could be like your capstone. See, it has a hobby project, not affiliated with Valve or Steam. Then how on earth were they able to get all my stuff? Well, because that stuff lives in a database. Valve exposes it as an API. They use that API to like build out their site. And also the Steam native app for phones also uses that API. And third-party stuff all uses that API. And like, you can do whatever you want with that data. As far as like playing a game in the browser, like a way that you might do that, this isn't actually how this is done, but could be, is that the HTML, the DOM thing is real simple. All it is like effectively showing a video. That video is like streaming real time from a real computer that's like playing this game. And when you type buttons on the keyboard, you have event listeners that are sending those things over across the network to the real computer that's playing the game. So you press A, and then A goes over the network, goes to that computer, and they go, "You said A!" And then an A gets pressed in that game, and then you turn to the left a little bit, and you're seeing that video in real time. It doesn't actually use HTTP. There's a different protocol for that. But that's basically what's happening there.
Well, thank you for answering my question.
Hit me with some more.
I have one more question. When you were on the website and you were looking at the GET requests, like just for example, when you were on the network tab for Steam, and then you'd copy the IP address, was the thing in the colon after that the request number?
No, good question. So over here, let's look at HTML requests.
Yeah,
you can tell me what this is. It was
Isn't that the port?
That's the port. That was one of your vocab questions, I think. So that's the IP address. That's the port I'm sending the request on. So that same IP address, that might have all kinds of different things that it does. So like port 5432 might be the port to their database. So if I was requesting, if I want to send a SQL statement over to their database and get something out, I probably shouldn't be allowed to do that from my browser. So it listens to requests that come from browsers on port 5432 and goes, "Nice try, asshole," and shuts it down. That's one of the reasons I probably couldn't just put that in the browser. But 443 is the standard port for HTTPS traffic. And so if I don't specify a port, it's exactly like I went like that. Or if I was on HTTP, it would be like I did that. There's tons of ports out there. 80 and 443 are like pretty much the only ones you need to like memorize. 22 can be kind of nice to know also, because that's how you log into computers remotely. But yeah, there's like hundreds of standard ports. Those are the ones that web developers work with the most. There you go. Quote of the day has an official port. 22, SSH. Mail servers use 25. If you have a server that just tells somebody what time it is, you should be expecting requests on port 37, and so on.
Awesome. Thank you so much.
Yeah, of course.
Just looking at this diagram, it seems like the core of a lot of this working right is the API.
Mm-hmm.
So like, I guess just thinking about it from a vulnerability standpoint, like how could you shield against like a sudden API, like a change in the API that could essentially like knock out your website or like just change it in a way that you have like zero control over? Like, what could you do to safeguard against that?
You can't. Let's see. There we go. Amazon snag, Amazon server crash, technical glitch. Like, this just happens. This is part of life. So how you protect against that is if this API you're requesting something to falls over, you need to have something that says, oopsie, something went wrong. Like when you guys go to a page that makes my server fall over and it goes, something went wrong. Like, that's how you handle that. Like things like, okay, but what if the server got compromised and Anonymous took it over and injected a bunch of malicious stuff in there? That's why you got to be real careful about, like if you just took raw HTML and then threw it in your page blindly, that's a security vector. Just data in HTML, even parsing the data doesn't like actually execute much on your computer. Because if it's not valid JSON, if somebody tried to sneak something in there that is not allowed in the JSON spec, as soon as you try to parse it as JSON, your browser goes, whoa, 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 this isn't what we agreed to. I was expecting JSON back. You gave me a script to run. But yeah, man, like, because this is super simplified. What's really happening is that same shape, but your browser is working with the Star Wars API and the OMDB API. And the OMDB API is using this other thing, which uses an API. And this uses this API. Like, its API is all the way down, man. This, like, whole network of data that people use, yeah, parts of this fall over. Happens all the time. Happens every day. And yet, here we are. It's a miracle.
Is that why some APIs cost money? Is because people have to sit there and maintain these and, you know, safeguard them and make sure they don't go down?
100%. Because, yeah, it's not free to maintain one of these. Like, it takes time, takes even if all you did was maintain the pokeapi.co domain name. All right, well, that's $12 a year. Like, for something that the entire internet uses, like, all right, why is that on me? Why is it on the person who did all the work has to like eat all the cost of this? And so then you get sponsors and you have other things that, like, the Poke API isn't fast. So you maybe have a slow free tier with just all your excess capacity. And then you have like a prioritized paid tier. So something like the OMDB. They have a free tier, and then they have a paid tier. And so like the poster API, where it's just posters, but you get like all of the posters for every movie. If you throw them a couple bucks, then you get access to 280 posters at super high resolutions. All right, well, like maintaining all of those posters and paying for enough bandwidth for everybody to have access to those things, yeah, it costs money. So they want you to pay for it. And then they'll give you a key that lets you know, like, oh, by the way, I paid for this. I'm good. And then you go up from like 1,000 requests a day to 1,000,000 requests a day or whatever else. But yeah, all these things are just labors of love from folks. And then there's places where the entire business is the API. So a good example of that would be like all the stock APIs. Alpha Vantage, I think, is one of them. But like a good stock API needs to have crazy high resolution. Like it needs to know like down to the millisecond when a trade occurred. And so the Yahoo Finance API, for example,
Is that latency number at the top? Is that what you're talking about, like milliseconds?
yeah, how long does it take for a request to come back?
Okay.
And there you go. So we've got a free tier, Pro, Ultra, Mega. Has to do with how many requests that you can make a month. If you're doing algorithmic trading, or if you're just using this API to provide your own financial services business to somebody else, I don't know, how many customers do you have? And so you might need to like progressively raise your service level. How many requests a second can you make? All of those are like part of the design of the API. And so, yeah, this is like one of the ways that Yahoo makes money is like by offering these APIs.
Did this kind of take the place of the old RSS feeds?
Yes.
Okay.
In fact, RSS feeds, spoiler alert, were APIs.
Oh.
You would go, let's see. RSS was all XML. Oop, there we go. Okay, so when you got an RSS feed, what you did was you requested this file. And it would go, okay, cool, here's the thing, and here's all the items in here. And then those items would all have these links, and they'd have titles. And so, like, when you click on the next episode of a podcast or whatever, that's where it got the URL for that from. But yeah, it's literally just an API. And so if this were done today, this would have been JSON instead of XML. But like JSON and XML do the exact same thing. JSON just does it in fewer characters.
So just out of curiosity, so like the Yahoo Finance API,
Yeah.
and kind of touching on what you said earlier, where it's APIs all the way down. So does that mean that's also relying on an API?
Could be.
And then, okay.
So part of the interface part of this goes back to I'm a person. I'm using, this could be a regular like consumer or a developer. All I know is when I ask the Yahoo API for this thing, I get the thing that I want back. Everything that may or may not be happening over here is not my problem. This is a black box to me. That's the idea of interfaces in general, is all of the complexity is hidden away behind something that you interact with. And so that allows Yahoo Finance the freedom to, no, there's just some other API that we use, and we just kind of proxy your request over to them and forward their response back. Or they could re-architect this entire thing. If they keep the interface the same, how would you know? You can't see anything other than these 2 points, and that's the way that you want it.
If I could backtrack just a little bit and touch on Amp's question again. When we're looking at a site such as Steam, we can go ahead and go in and inspect it. And you probably saw up in the top right corner, there's a little install button. This would be like the same for Spotify or anything else. So we can agree that this is all running on HTML. When I install it, is it still HTML when it's an app on my desktop?
All right, that's a great question. Let's see if it will track all of this.
Because I definitely can't inspect my Steam app, at least as far as I know.
Okay, so clicking install, still just loaded another page, so nothing special so far. I go, okay, well now I want to install this. Take a look at this URL. That .deb at the end of that, that's a .debian. That's like how you install something on Linux. So when I click install Steam, all it did was download the file. It didn't do anything.
And so that file is still pulling all the same stuff from the same Steam API or the same Steam database.
Yeah, presumably. So yeah, that's like, all right, instead of a mobile app, well, then it's my Ubuntu desktop app. Data all comes from the same place. More questions about how APIs work? Starting to get nervous about running out of space on this. Or big picture, HTML, CSS, JavaScript, how all the Lego pieces go.
I have a question.
Yeah.
So when looking into like deploying websites,
Mhm.
like a lot of the stuff we had to use for our pre-work exercise said that, oh, you know, this can handle static websites, so HTML, CSS, and some JavaScript, right?
Yes.
So at what point, you know, will we not be able to use like GitHub Pages and like those simple static page deployment websites?
Oh, that's a great question. So there's no actual limit. There is a practical limit, though. I'll show you what I mean by that. Okay, back over to the LMS. This build folder, I do npm run build. So what it's doing is it's taking all of the like goofy stuff that I made, all that JavaScript and React code and things that looked like HTML that weren't actually HTML, and the actual HTML file. And what it's doing is it's turning that into HTML, CSS, JavaScript, period, the end. So it cranks through all of my code and outputs a teeny tiny HTML file, a medium-sized CSS file, and an enormous JavaScript file. And then when that finishes up, I end up with all those files in a folder. I could put that on GitHub Pages. The problem is that I would need to run this build command every time. And anything that you do by hand every time is something you're going to screw up sooner or later. So what I do instead is have what's called a build pipeline. And those look like this. Oops, not. Nope. Nope. JS. So whenever I push a new file to the master branch on this, it does all of these different things, including like swapping out a couple placeholder variables that I have, running that build command, and then taking all of those files. And then I don't host this on GitHub Pages. I host it on a service called Netlify, which gives me a little bit more control than GitHub Pages does. And so then I take all those files and send them over there. And since I also have an API, all of that needs to get done also. So similarly, swaps out some stuff, and then takes all of the API and database stuff and sends that over to Heroku, which is the service that runs the API. So there's a bunch of tweaky steps to that, and if I did them all by hand, it would take like 5 minutes, and I would screw it up every other time. So instead, I wrote it all out as code, and now the computer does it for me every time I push it to master. That's the practical limit. Anything you have to do that manually, you'll mess up. So you turn it into code. All right, well, once you've turned it into code, I can't just say, all right, deploy this repo GitHub pages, because there's too many steps to it. It doesn't know how to do all of that. But I can use something like a pipeline to automate all those steps. So that's the limit. This page here, or this folder that I just made, all of this JavaScript. See, it's taking so long to load because it's huge. This is probably like a gigabyte or a megabyte of JavaScript. It's quite a lot to load into a text editor. But yeah, just that folder, I could put all of this on GitHub pages, no problem. CSS. This is all of the CSS for the entire LMS in just one file. There's the HTML file. And then all this stuff, like images and what have you, like, yeah, those just get loaded by the browser, usually through HTML. Ta-da!
Okay, thank you.
More questions? Cool. Hopefully how HTML and CSS and JavaScript and the browser and APIs makes like at least 1 degree more sense. Cool. All right, so I'm going to stop that recording there.